I'm not recording. Anybody else facing issues on Windows? Yes. Your permission will be denied. Are you using the PEM file like we are using here? And you're SSHing into that port at the port number 22, which is default, right? I mean, it's not there here, but so you can do -22, -P22. If you're getting permission denied, then maybe that file should be okay. Let me just show you. So this file here, that's not there. Oh, this is that server. Sorry, let me exit. Yeah, this file's permission could be changed. Okay, that could be one reason. So okay, you are getting a permission denied error. Who else is having different errors? Yes. Same error. Okay. What else?
Just a quick question. Could you add the connecting computer's IP address to the IP address of friends in the function server?
Connecting to IP address of what?
So like I know on Linux you basically have a list of trusted IP addresses.
Yes.
You don't necessarily could you add that to the function server?
Yeah, first time you connect, it will say, hey, is the fingerprint of that server correct or not? You'll say yes, and it will be fine.
Oh wait, I mean like the EC2 say like, oh, pre-build this server with these IP addresses.
Oh, okay. You want to whitelist IP addresses? That's a more complicated problem. We'll talk about it during the break, perhaps. Yeah.
If we shut down the server and then log in, because yesterday.
Oh, shut down the server on AWS? Then yeah.
Like I did that. Like I basically stopped the terminal that, and now I started it again, but it's not accepting my key for some reason.
Oh, you restarted the machine?
Yeah.
Or did you terminate the machine and create?
Not terminate. I just stopped it.
It's not accepting your key.
Yeah.
What is the error?
Like it's not refused our server refused our key.
Okay.
Yesterday it was working fine. Right.
Okay. So server refusing key, permission denied, permission denied. What about others? You're fine. What about you guys? Any issues with? Okay. Anybody else has issues? Yeah.
When we are running the py code,
yeah. Yeah.
File name was class _simple regression service.
Yeah.
So when I'm writing Python and the file name, so basically I should be able to access this file, right? After writing this piece of code.
No, it will be running on local machine. I mean, you will have some output that would have come, right? Or is that not the case?
It is saying that no such file or directory.
I mean, if you're not in the right directory.
But I am in the right directory.
Okay, so actually, let's start the class at 6:30. Okay, people who are not who are kind of don't need the debugging, you can relax for some time. Yeah. No, okay, this model is not there. Okay. No, data. There's no folder for data. That's the problem. You know, just you need to create a simple regression of people. Is this fine? It's not there. So go to class example, not class example, right? Model example regression and run it. You'll get a pickle file. Okay. Copy that into the into this.
Okay. Okay. So basically,
you want me to do that? I can do that.
I can do that. So basically, I will use the get your function.
No, I'll show it. But yeah, can you please show me what you heard? You are on the server already. But you are on the server. Why is there permission needed? That will take a second. Not yet. And we have to maybe copy as yeah, yeah. Yeah. Yes. They fix it. So the tunneling part is I'll do that. So you need to create you have existing right and all fine. So when you create new for the specific you can scale it up if you want. Otherwise, if you want to use the same key for another one, just get new one. So you need tunneling. Anybody else have an issue on this side? So you have the directory. The file missing is a minor thing. I'll just show you. Anybody else? Any issue? Yes. What is that?
Like when I use the keeper again, it asks me login as I don't know. It never asks me this.
Try Ubuntu. It should not be the case actually because it should use the key. Okay, it did not. Okay. You are done, right? Then it's fine. Okay. Tunneling is something we'll do right now. Tunneling to get the browser Jupyter stuff. Do you have an issue? No, you're good.
And secondly, one more
What's
few
it?
more things. Yes. Well, because whenever you when like what I did was
Yeah.
like I got this mini conda along
Yeah.
with chapel.
Yeah.
I got all of that.
Yeah.
But when
You're going to directly and execute something, you have an error.
not an error, it's something like this. We
Yeah.
went there.
Yeah.
What was the file?
Regression one. I'll show the regression one in a second. Okay. Yeah.
Secondly, Control C, Control V doesn't work in this.
Control C, Control V doesn't work.
Doesn't work in this.
Then use the mouse.
Yeah, that mouse.
Yeah, for now. We'll kind of tunnel and we'll hopefully it work. Okay, for people who are remote, I was just trying to debug some issues. So let me summarize. The issues are tunneling for a couple of you, permission issue, which I think is kind of new to me as well. I mean, if there is no, I guess, important data there, why don't you recreate a machine with a new key file and see if that still has the same issue? Okay. So we'll work with tunneling and the MLOps example regression stuff. Okay. That's what we'll try. Okay, so let's tunnel. So let me also add a -I. Okay, minus I is the identity file or PEM file, and then the most important thing is minus L, and then I mean it doesn't have 8009, so let's choose 9001. The number of ports, I think the max is 64,000. So just you know, pick a value between, let's say, 10,000 and 64,000. That's kind of a good range. Oh, what happened? Okay, there was some shift in the um, right. So you should be able to get to this by just running that command, right? So sorry about the shift here. This string should be over here, okay? Somehow a display error, but it's just the important thing is use the same temp file, also same command. The most important thing is like this part, okay? This is a local machine, like our laptops, browser, in the browser you want to type this, and on the remote machine, on your AWS machine, hopefully you're running Jupyter server the way we saw in last lecture. I mean, if you're running it default, open to the world, then it's running at port 8888. Any issues with just running this command? Okay, if you run it twice, then you may sometimes get a port is occupied error. Then just change this 9001 to 9005 or something, and then use that in your browser. So right now in my browser, I'm using 9001. Okay, so it's the same Jupyter server that was running since last, I guess class. So we'll get to the ML, simple regression example in a second. Tunneling people issues. Is this something that you were not able to execute? I don't see anybody. It's okay to, there's no pressure. Okay, we have some time. What today's topic is about Docker, and we can scale up and down the content as needed. But anybody has issues? Yeah. So this should be what you should do, right?
Instead of like PEM file, I have a PPK file.
Yeah, that's fine.
That's fine. I can just change that in the command.
No, but PEM file. If you're using Gitbash, you should use the PEM file.
No, I have to redo all of this. Probably I'm going to go home and redo it on Gitbash.
Okay.
Okay. Because right now I have a PEM file.
Okay. PPK file.
Yeah, a PPK file. Because it has.
Yes. Yeah, you need to get it. Yes. If you have that file, yes. You need to create that file. Did you create that file? Yeah. Pretty well. Yeah. Yeah. Try it. I mean, I haven't tried the PPK version, sorry. But try it. Like, what's preventing you from using Gitbash the way I feel?
I think you mentioned in the last wedding.
Could not resolve both names. No, there should not be a space between the two alternate. And also the PPK file. No, it said converted. Anybody else? I'm going super slow here, but we'll once we are on the same page, then we'll yeah. Okay. change the file permission to read only. So you change the right of one permission. Okay, I just check. Yeah. Permission denied. It's not accessible because the file is not there. You're saying that is there, it's not there. That if you can find, let me come back to you. Yeah, but okay. So for people on Mac, if it says permissions are too open, you should use the chmod command, okay, to change the profile permission. Okay, for people on Mac, sometimes the PEM file will not be secret enough, in the sense that if it's readable by everybody, then that's an issue. So here you can, you should use chmod. Okay, chmod, this is something like 600. Okay, sorry, the space 600 and then file name, something like this. Okay, before you kind of use the SSH command. I mean, before you want to SSH into the any SSH command actually. Yeah, let's say. Is it good? Who has the issue? Please try it. You know, it's just a 30-second thing. Who else still has an issue? Logged in, everybody. I mean, after that, you should try this, right? I mean, log back out and try this command so that you can get Jupyter. Unless you have not started Jupyter there, then of course you need to do everything that we did in the last lecture to download Miniconda, run Jupyter, copy the token, you know, get that, you know, there are a few steps. Yeah, because this is running on the virtual machine. This Jupyter is running on the virtual machine. After running that command, you know, this Windows machine, by the way, is not even mine, so I can't run Jupyter. Right? It's university's ones, but I'm just logging into that machine using this SSH tunnel, and I'm using Jupyter there. Anybody else? I mean, for the purposes of today, maybe you can run Jupyter locally, but it's up to you. Okay. For best experience, you know, it's better to have something running over there. Anybody else has an issue except for who else has an issue still? You're good. No, you're still. You figured it out? No. Try to use Git bash, right? Why do you have to use Git? Whatever that's pretty thing. You have Git bash. Right?
You just mentioned the first that I have
But you also have Git bash. And that's not, yeah, you just need to figure out where that file is. That's not difficult. Right? Do that. Yeah. So that is the whatever. Yeah. That is, I think, kind of makes it easier if you want to follow the Docker side. Yeah. I think we are running out of time for some of our students, but let's see. Yeah, because I want to use the Jupyter on the server. I don't want to use Jupyter locally. Right? Locally, I don't need any software except for the PEM file and Git file. Yeah, but this Jupyter not going to be running well. So it's already in your remote machine, right? Why do you have to? Then why do you have to? How did you get here? Yeah, to get there, yeah. Tunneling to get to this. To get to this.
Slash down. That's what we done flash. I don't have That's disgusting.
So you're already on that.
Okay. Yes. Yes. three.
So now that's the tunnel.
Nice.
But that's just if you reach another difference, hopefully that's the one running over here. If you have started with that, if you're not, then it's not.
You know who Travis?
Otherwise, you are connecting from local machine. Yeah, but the tunneling command.
One guy.
Well, him like a bunch of things. He's been working on it since like 2000.
Anybody else? Any issues? Okay, actually, we'll start.
One question.
Yeah. Yeah, so the tunneling works. So go to your browser and 9001 and see if you can. Did you start with your Then it's not working. You need to start with there. Follow 9001, whatever I do. But it will not work because you don't have filter over there. So what you need to do is not tunnel, but first time you need to log in and start filter over there. That is there covered in the last section. Yes.
There's a bunch of complete tab complete button.
Tab complete, no. Okay, so it looks like everybody is tunneled in. So what I'll do is so this is from actually from last run, so you can see everything is run 7 days ago, but most of you must be here, right? So some of you are pretty comfortable up to this point. So MLOps code example was what we downloaded last time, and somebody has an issue with running regression, right? Regression example. Anybody else has a similar issue or not reached a stage yet? How did you get to this folder? Just download it. Right, so actually if I do up commands, maybe I'll see. Too much history, I guess. Yeah, so I ran this command and got the folder. Okay, so we'll talk about Git potentially. We don't have time to cover Git version control in this short series, but this is how I got that folder. Okay, instead of this, you can do other things. If you have a zip file, you can also get the zip file directly here. Okay, but those are commands that I don't want to spend time on right now. So during the break, if you have locally downloaded the code, but you want to send it to the server, I can help you with that during the break. Okay, so this is how I got that folder. Once I have the folder, I mean, you'll see basically a folder like this. So what I did is I made some changes, right? So if I do git status, you'll see that git again is a command line utility, just like SSH, just like CD, just like ls, and so on. I'm just typing this just to show you that I have already changed some files, and that's why you will see that I was able to execute Flask and you were not able to. So let's actually see what changed. In particular, in the first lecture, probably I changed last simple regression example. Okay, and that's why it worked, and for you it did not work in your case. So if you want to see what changed, let me just check what changed. So if I type this, you'll see what changed. Okay, diff is just a difference between what changed and what should have been. Okay, when I downloaded the folder. So it says first of all I deleted pickle. Like maybe if you make these same changes, you'll be able to run. Okay, just this one. Deleted pickle. That file that was didn't exist, I deleted it. Okay, the lines which are calling that file which didn't exist. I mean, we can create that file, but I didn't want to kind of spend time on that. I just created a line which is in green called model params is equal to just a list with a couple of numbers. You can choose whatever numbers you want. So instead of importing a model, I just created a list. Okay, and everything else is the same. I mean, this part is kind of irrelevant. It's just showing if you go to MLOps, you will get hello world. Not relevant for us. Okay, and here I just changed the location, but this is also not relevant. I mean, not important. Okay, so if you just want to run the Flask example, just comment out the import pickle file, the 2 lines, these 2 lines here. Comment out these 2 lines and just create a list with this name. Is that fine? Yeah, and then if you run, you'll not get that error. The thing will run, but if you have not exposed port 5000, by default, you will not be able to access it on the public server, publicly, sorry, from the browser.
So this is to edit the part, how I need to use the web function, right?
Yes. So I'll actually show you. So Vim Flask example regression, Flask regression service. Sorry. Right, Vim with that. Okay, if Vim is not available, then there is a different command. So type Vim space file name, ideally, press enter, right? So you have, by the way, you don't have to use Vim actually. I mean, you can actually directly do it here. Okay, it's the same thing. On the browser, on the right hand side, you can do the same thing. But if you wanted to use Vim, you can use Vim. You can see what I changed, right? So I just deleted. So I deleted those lines and just created this line here. Line 8. Oh, it was updated. Oh, if git pull, if you do a git pull again, if I did not update the code, then it will say it's already up to date.
That's what I'm saying. Did you update the code last
No.
Today?
No, I didn't update the code at all. So if I don't update the code, then when you do a git pull in that repository, then it should say, hey, it's already up to date. That's what it did for you. So if there is some changes, then it will pull it. If there's no changes, it'll say, hey, it's already up to date. Okay. Anybody else? Any questions? Any questions?
Question with one of the other examples. If you are ready to take that.
Yeah. We ran multiple examples of, if it's class related, we have done most of them. So just tell me.
So this was the recommendation.
Recommendation one requires PyTorch, right?
Yeah.
So did you install PyTorch?
I did a conda install PyTorch, but it's still looking for the package. It does not.
No, it's not conda install PyTorch, right? If you go to pytorch.org, it will tell you the string which you need to use for installing PyTorch.
Oh, okay.
Yeah. So, sorry. So here, I would suggest pick CPU. Okay. Stable, I mean, Linux, conda, Python, CPU, and then this is the string that you need to use. Okay. I mean, we use PyTorch for this. Okay, so the recommendation example is a little bit more complicated, but Flask ImageNet, right? So this service, ImageNet service, we have done it. It also needs PyTorch, right? So it needs torch and torch vision and so on. So, but this example runs. We actually ran it last time, right? Yeah. So the recommendation one has its own quirks, but yeah. Anybody else? No questions? Okay. So I want to.
How old are you? How old are you?
Okay, so what we'll do now, sorry for so much time, but what we'll do now is for the next 10-15 minutes, 10 to 20 minutes, we'll try to finish up Lambda function and cloud function. Lambda function there was no error last time. It was just, I'll show you where the error was on the client side, not on the server side. So we'll redo it and then redo the cloud function. Okay, that will be the wrapping up of the previous lecture. Okay, and that doesn't require Jupyter to be running. So in case you are not able to set up Jupyter on the server side, you won't need this yet, but we'll use it for Docker. And Docker also doesn't need Jupyter as such. So I'll tell you when we get to Docker, how to site set Jupyter and still work. Okay. So Okay. Yeah, so last time, if you remember, let me yeah. So yeah, so last time what we were trying to do was set up a simple Lambda function on AWS Lambda, and then make a query. And it was the function was actually just a recommendation model. In fact, it was a kind of just a scaffold because it was not really reading anything. So let's redo that, okay, today from scratch, and then we'll make a query. Last time, if you look at the lecture recording from last time, the difference was last time I was using data as a parameter here. That was the wrong parameter to use for the post request. I was supposed to use JSON. And so that was the only difference. Otherwise, you would get, you get back the response. In my case, we had just the A comma B as a movie name, so that's what we got. Otherwise, everything else should be fine. So we'll redo it right now. Okay. How do I do it? Okay, so let's quickly create a function. Create a function. So I just chose a name and the runtime, which is Python 3.9. And the script itself, we'll get it from, we can get it from here. Okay, so we have this Lambda handler. We're just going to replace it with the function here. Okay, and we'll also get rid of top and, I mean, so we'll uncomment this just so that, you know, let's just give some different names. Okay, so now we'll drop this loading. So we went through what this function has, right, in different parts. It's just trying to find, hey, whatever, it's very similar to the class function, except in the event object, we're just trying to find if it has a body. If it has a body, then does it have, if it doesn't have a body, then change it so that it will have a body, hopefully. And then if UID is there in that, dictionary that you have. If UID is there, then you can respond back and say, for this user ID, what should be the recommendation? So it's just trying to see if event has a body, and if it has a body or not. I really want to get to see if you want to pick if UID is there in that event dictionary. That's all. Okay, that's the logic for the first few lines. And once if the UID is there, then you just make a prediction. For simplicity, I didn't include the JSON files, but we have seen the JSON files last time. It's there in the it's there in the folder, I guess. So this, if we test, okay, test one, and we just pass in, I think 196. Yeah, 196 is the only user ID here. So, okay, so this is the response you get. Okay, I mean, okay, this was not the right response. So, okay, let's see. Um, okay, I should deploy it first. So whenever I change the code, you should also press deploy to kind of deploy the code and then run test. So okay, so it says everything's good, success is true, and then you got this locally, and we saw this last time as well. So what we've done so far is just catch up to what we did last time in terms of correctness. Now last time we couldn't get the like we connected something called the API gateway, but we were not able to make a request and see that from any third place, for example, from our local Jupyter instance. Okay, so that's good. So far locally this function runs. Okay, that anybody has any questions regarding this? What I did is just change the lambda function based on the example that we have from here, and create a new test. Also press deploy, because if you change the function, you need to press deploy. Otherwise, that's where we are. Any questions about this after this? I know we are doing it in a very fast way. Best course of action is to actually look at the tutorials on AWS's website. But our objective is to just sample a few ideas. Remember, the larger context is web servers on one end, serverless on the other end, and Docker somewhere in between. We tried web servers in lecture 1. Serverless is something we tried last time, and today we're just doing a review, and then we'll get to Docker today. Okay, so that's the bigger context. And so if you're not able to follow every single step, do reach out to me during the break or after the lecture. Okay. Okay, so now what we need to do is create a trigger or a gateway, and this is the same idea both in Google Cloud Function or here. Cloud Functions are here. So we'll pick an API gateway, and okay, we'll just create a new API. And security will currently keep it open to everybody. Okay, and so after testing, we'll kind of delete it, but this is just for temporarily to get something up. Okay. Ideally, you should not do this. If you plan to keep the function for a long time, you need to look up some documentation to figure out how to secure it. Okay, so that's the link. Okay, so right now, if we click on it, it actually triggers a function, and success is set to be false, and that is what is returned already. Yes, the function is actually already triggered. So now we just need to copy this, and actually I didn't tunnel on this machine, so let me create the Jupyter thing. So again, this is actually I'm logged into tunnel through two different locations, my local laptop and this Windows machine from the classroom to the same Jupyter machine. Okay, so you will see the same thing. So now we've tunneled. So let's actually use this link. That should not work. So let's try this. Okay, so So I just created a new, this notebook is running on the server. Okay, you can always do it locally if you have Jupyter on locally. So import request and then just run the cell that is relevant. Okay, this cell is not correct, so don't worry about that one. You actually don't need all these extra stuff. Actually, let me drop that. Okay, so it's just saying, hey, what URL you want to post to and what do you want to post. You know, if you want to post a JSON object, basically a dictionary in Python land, and then what the content is, it's just lambda and function. Okay, so this actually, as you can see, it's not exactly a dictionary. It's actually a what type of it is? It's a bytecode? No, it's not a bytecode, but you need to kind of process it if you want to make it a dictionary. So it's actually JSON dot load from string. Okay, now it's a dictionary. Okay, now it's a Python dictionary. This whatever resulting object has a success, Boolean response key, and then this is still a string. If you want to make it into a list, then you need to do further processing. Okay, is that clear? Any questions?
Is that a list already? It has two brackets.
You can check. Type. Let me just. Oh wow. Okay. So, what was the string actually? So first one is a Boolean value, and the second one is actually string. Okay. Yeah, so you need to further process it. In fact, you can print it also. That's the string. So you'll need to do some processing. Okay, so are we fine with comfortable with AWS Lambda function? It was pretty quick, like a minute of creating. We already had a template example, so we just copied it. Of course, the complications, as I think I mentioned last time, is creation of layers. So let's come back here. So you can actually create layers if you want to have, for example, SciPy, NumPy. Otherwise there are some other ways listed in the notes to create that dependency, because by default those such dependencies are not there in the runtime. Okay, so if you want to have pandas, then you'll need to have some way to get them in. Okay, so either through the notion of layers or through locally zipping them up. Zipping them up, the problem is it bloats up in the file size. It's maybe 200 MB, 500 MB zip file. Lambda has limitations on how much how big of file it can uncompress and stuff like that. Okay. Any other questions here? Okay, no. Okay, so what we'll do is let me try to log into Google.
Has to be that.
Okay, so I logged into a Google account that I have. I mean, I just needed a separate browser window only because UIC also has a Google account, so just wanted to keep it different. So here you can search for cloud. First of all, you want to create a project. Okay, a project is basically an idea in Google Cloud is a little bit different from AWS, where you kind of encapsulate all the resources that you're gonna spin up or consume or create. You can encapsulate them into a project basically, and so it kind of makes it easy. For example, you know all the resources that you're using in a project, and so it's easy to kind of delete the project and then delete all the resources that were related to that project. Okay. So first time you log into or create a Google Cloud account, you'll not have a project, so you can create a project, right? Like new projects here, and then you can start using Google Cloud Function or any other service. Okay. So let's create a okay. So right now it's saying, hey, there's some project name and all that, but it doesn't say, I mean, there's nothing else going on. So now we can start using Cloud Functions. And while the demo is, takes a very short period of time, I would highly encourage you to look at the tutorials on the right-hand side, deploying Cloud Functions and so on. So the interface is very, I think, very similar in flow to how we created one for Lambda function. Okay, so here it already kind of asks you some defaults, function name, trigger type. It already is giving you some URL. Authentication, for now we'll say unauthenticated, HTTPS. I don't know. Okay, let's keep it. So, okay, runtime build and settings like that. There's some choices, right? So how much memory should the whole thing have? Whole thing in a sense that behind the scenes it's a service, right? For us, we are only concerned with our function or basically our script. But behind the scenes, it needs to allocate some resources for your script to run. It's just asking how much memory does your script need, okay? And a few other details like security connections and so on. We'll mostly keep everything default, I believe. We can save. So we didn't change anything here, and then do next. And then very similar to AWS Lambda, it will ask you what what runtime you want to have. So we, instead of Node 16, we'll use Python, any one of these. Let's pick Python 3.9. Okay. And the entry point is very similar to lambda underscore handler. So entry point is a which function needs to be triggered when somebody hits that URL. Okay. So hello underscore world is the name of the entry point. You can change it if you want to use some other function. And the big difference from AWS is that you kind of need to give a main file or whatever your Python file, as well as a requirements.txt. Okay, requirements.txt is a format where you can specify which packages you want to have. Okay, it's one way to have some portability. For example, if you work on some Python project, but you want to pass it on to your team member, but there's some dependencies. Of course, they can open the file and see what the dependencies are. But you can also specify the dependencies in a requirements.txt file, so that the other side can easily use pip install from the requirements.txt. Okay, So they can install all the packages that are listed in the requirements.txt. And in requirements.txt, you can also specify which version you want. Okay, so pandas, 0.20, scipy, 0.19, whatever, whatever specific versions you want, you can specify that. It's very similar to if people have worked with JavaScript and packages.json, then you need to have whatever dependencies are, you can certainly specify greater than or equal to or whatever, like dependency numbers, right? The version numbers. So that's what you can do here. Okay. So you can see that requirements right now there's none. Hash means this hash starting is common. So there's no dependencies because the main.py is just doing hello world here. So let's just deploy hello world and get a feel for how it is. Yeah. And if you want an example, the example is there in, there's an example in our MLOps code examples directory. It has a cloud function example subfolder. We'll pick up that example. Okay. So the first time you create this, okay, there's some permissions issue. Okay, actually the permissions is because I think it clearly says here cloud build API is required, and I didn't enable it. So let's enable that. Oh, I need to create credentials as well. Okay, let's try. Okay, so I mean, it summarizes what all we chose, right? So we chose some name, what's the trigger, HTTP based trigger, Python 3.9, and next the function that gets triggered is hello world and all that. And here you can actually see you can test the function very similar to the way we were doing testing for AWS Lambda. You can view logs. I think in AWS Lambda, there's CloudWatch, where you can see what happens when the function gets triggered. So for example, you might typically see internal server error. Okay, that really means there's some issues with your script itself. Okay, so if you wanna debug, and if you uploaded your own Lambda function and you're getting internal server error, it's not so much about hitting the endpoint. That's all correct. It's just a function while picking up variables from whatever you passed on, it may not be processing it correctly, or there is some issue in the function which is causing it to fail. Okay. Okay, so function details. Yeah, sorry, trigger. So the trigger URL is here. So we triggered a function. I mean, I didn't do anything. This was the default function, so it says hello world. But now you can imagine. So what do we need to change? Again, if you look at the you just need to change this. Your function hopefully is in main.py, and the appropriate packages that you need are in requirements.py. Okay, requirements.txt. So we'll actually do that. Yeah, so let me switch over to a different tab. Okay, here I'm just, what I did is just navigate into MLOps code examples and cloud function examples. So we have those two files. The first file is a slightly modified version of the Flask example that we tried out a couple of times before. We literally get the model, Okay, we are doing something more complicated here. Okay, maybe I'll delete that part. But to get the model and make a prediction. Okay, so what else is going on in this script is that we are actually connecting from Google. So we're connecting to Google Cloud Storage, which is a different service. Okay, stored service from which we are picking up the model. Okay, and then using that model, storing that model locally. Storing that model locally, and then reading that model using pickle, and then updating the model. Okay? Now you can imagine all these steps. Should they happen inside the function or should they happen outside the function? The problem is to have this instantiated outside the function is hard because when the URL is hit to the endpoint, it's just a function which is called. Okay, the initialization. You need to check whether such initialization can happen before the function is called or not. Okay, so anyways, this is just initialization code. What I'll do is not do all this. Clearly, that will require using a different service. So I want to keep the example simple. So I'm just gonna create a. So similarly, you can see that in requirements there is Flask, NumPy, and Google Cloud Storage. We'll probably just use. Actually, I don't think we even need to use NumPy, so we'll just use the same example that we did for AWS Lambda. So, any questions or people are lost? Not lost? Okay.
I'm digging a tunnel. It's a face tunnel.
Any questions on this side? So we're just gonna okay, let me actually edit this site here. We don't need to sign. We need JSONify because it's needed over there, and Google Cloud is not needed. Pickle is not needed. Yeah. So this is fine. And then requirements. I don't know if we need NumPy, but let's keep it. Okay. So I'm just going to copy them into those into Cloud Function panel. Okay, these two. I mean, I'm not specifying the version, but okay, some change needs to be done here. Called predict. So I'm just going to drop predict here. Simplicity. Okay, so we can import from Flask only because it's there in the requirements, so it will be installed. And then I'm just saying, hey, create a model called with a slope of 10 and the intercept of 20, and then that's it. So request .get JSON will make a JSON object from there. If there is a if you pass a JSON thing. So what we're doing in this hello world or this example is we are dealing with both a JSON. So if you pass X as a GET request, then GET request gets processed. Else, else if you pass a JSON object, then via post request, then that is also processed. Okay? So it's just the logic to deal with both a GET request and a post request in a HTTP protocol. Okay? Yeah, so let's try to deploy it. Oh. That did not work. Yeah, so I don't know why the curl request was incorrect, but it's the same function. I just clicked on it, and right now I did not pass an argument, so that's why it's saying, hey, x was not passed in. And let's pass x is equal to 10.
There are ways like we were passing arguments from the URL rather than like you can open a dialog box where you can pass an argument and run the command.
Yeah, we can open a dialog box. Yeah.
We can do that.
Yeah. So in fact, we can do that. So I'll come back to your question. So I just wanted to finish up this part. So you can see that cloud function was deployed, right? I mean, there's nothing complicated. You just have to ensure that your function definition is nicely formatted so it can take care of the request argument. So just as long as you can take care of this part, right? So it's very similar to Flask, both AWS Lambda and cloud function, very similar to Flask in terms of the function definition. Okay. You just have to somehow figure out how to deal with the request object, and this already gives you a template. As long as you can pick up from request X, you can pick up any variable that will be passed on for any other application, right? So this is just glue code that will be common once you see it. I mean, kind of reuse it every time. Same thing with the AWS Lambda as well. In Lambda, you have to do a little bit of massaging with the event object. Here, similarly with the request object, but otherwise, once you get through that, it's all very interesting for you. You know, in your application, what do you want to do with the input variables? You can work with that. Any questions at this point? So I was gonna trigger. Yeah. So now it changed. So I hope people know in Jupyter you can use the exclamation mark and use a command line tool in Linux, right? So you can do like this as well, ls, right? So I just use curl. Curl is another tool, just like request package, curl, and then browser based making a request. So these are all ways for clients to talk to a server using the HTTP protocol. Okay, get or post. Okay, and just let's see if this works for. Yeah, so we were able to both make a get request as well as a post request. Whereas for Lambda, I think I don't know if you have handling for get request. We only did post request. Okay, so that's the quick summary there. And Taib asked if we can have an interface. Yes, in MLOps code examples, we do have an interface example as well. So for example, in regression, let's see in regression. Yeah, regression improved. Has that example. Okay, so I think let's see if it has. Oh yeah, like if you want, we can try it, but I would say just not to do it. We can move on to the next topic. But try regression improved inside the example regression, or you can also try ImageNet. Okay, there in ImageNet example, you'll be given a browser window where you can upload your image. Instead of that, you could always input a number. Okay? So it was done last time, so try it out. Okay, and all this can be done using Lambda as well. The challenge with Lambda is it's stateless. So when you don't pass anything, if you want, so if you don't pass an argument, so you get a static web page. Okay, and if you want to make a post request, just like so, you just need to embed that post request in this. This type of post request, you just need to embed it via that web page. Okay, that's all. So the post request in your web page should hit the Lambda function and pass the JSON object, for example. So Yeah, and if you don't post anything, maybe the default can be the template with the HTML text and so on. Yeah. So okay, so with that, we just demoed very quickly both the cloud function and the Lambda function. Now next we'll go to Docker. So I think it's good time to take a break for 10 minutes, and then let's resume. Okay, so now I'm back to a different machine, but it's all connected to the same Jupyter lab. Okay, so what I'm going to do now is move on to module 3 and get exposed to basically the idea of Docker and containers. Okay, this is just I didn't share my screen. No, I'm sharing it.
Okay, yeah, you are.
Okay.
Yeah, you are.
Yeah. Okay, so this is module 3, and so what we'll do is maybe we will not get to Elastic Container Service, which is deploying Docker on a AWS service, but we'll kind of at least make headway, and hopefully the goal for today is to at least get exposed to container. What is a container? And there are a few vocabulary details of different moving parts here, like what is an image, what is a container, what is Docker engine, what is the Docker CLI, there are a few words like this. So we'll try to disambiguate and also understand like what is the larger context of this technology. Okay, so let me come back to the syllabus. So the learning goals for this module are the following. Okay, be able to reason about the pros and cons of container technologies. They are ubiquitous in most tech companies these days, especially when the product is also tech focused. In general software engineering. So it also makes sense these days for machine learning as well, because machine learning is like a subset or a special use case for much of software engineering to deliver predictions, to deliver recommendations, and so on. Second key goal of this module is to understand the difference between a virtual machine and a container at a conceptual level. Okay, so what's the and the short answer is virtual machines are more heavyweight, and so they have a few more moving parts, and containers do achieve something similar, partially similar to what virtual machines achieve at a lower resource, at a lower requirement. Okay, and we'll see what the difference is. We will try to create a Docker image from Dockerfile, ideally today, and maybe also run a container. Okay, simple containers. Actually, we may have examples in our folder. We have a couple of examples, so we'll try them. And the final part we may not be able to get to today, but hopefully next week, which is images are like just objects, just like pickle files or just like CSV files. You want to kind of put it somewhere else so that your team can use it, you yourself can use it, maybe on AWS, maybe some other machine, and so on. So where you put this image or this particular file is important, and so we'll see how to put it in a registry, what is called a registry. Okay, so it's very similar to how, for example, if I want to share code, I put my code on GitHub so that everybody else can clone it, right? Similarly, image can be put in a registry. If it's a public registry, everybody else can clone it. Okay, what's the point of cloning an image? From an image, you can create containers. So if I create an image and put it on a public registry, other people can clone it and then create the same container that I wanted them to create. Okay, so anyway, so here I'm just trying to give you teasers of what the goals are. Understand the core pros and cons of containers, differentiate with virtual machines, what is meant by Dockerfile and how to spin up a container, and eventually put the thing which creates containers, which is called an image, into what is called a remote registry or a registry in general. Okay, that's those are the 4 goals. So okay. Yeah. Actually, I wanted to show something else, which is I'm not sure if I'm sharing that. Am I sharing the whole thing? No?
I don't know. You hit the control somehow.
Okay, so with serverless, this is what we did, right? So there was basically some configuration needed for what is called a trigger or gateway, and then behind after that, the core thing was the definition of the function itself in Python language. It can, instead of Python, you can use JavaScript, you can use other Ruby and all that. So that was what we kind of saw, and then behind the scenes, either AWS or Google or many other vendors who all do some version of serverless solution. Behind the scenes, they'll take care of security, scale, resiliency by just choosing some GUI parameters. And you don't even have to use GUI, but that's one way to do it. In fact, most of the things that we're seeing in this in the last lecture and early this lecture, where we were doing by hand, typing the name via the interface, there is actually command line tools for AWS and Google Cloud, literally called AWS space. You can give a command. They're very similar to SSH space. Do something, right? So and you can also specify what you want in text files. Okay, something like text files. For AWS, there's a proprietary technology called CloudFormation, which is a certain type of text file through which you can create a cloud function, also through which you can create a Lambda function, for example. Okay, you can also use non-vendor or vendor agnostic such text file creation tools. Okay, to also do the same thing. So I'm just telling you that to achieve the same goal, there are hundreds of ways, and we saw that even for creating Jupyter or logging into a server, right? There were, with just Windows, there were like 10 different ways to get to the machine. So for each and everything that we're seeing in this lecture or in this course, there are many different ways to achieve the same thing. Okay. Anyway, so we use the GUI to create serverless functions both in AWS and Google, and we tried out with different clients, curl, request library, as well as through the browser. Now, we didn't get to use the CLI commands. They are called literally AWS gcloud, gutil, and so on. But maybe maybe in the future lectures we'll get to use them. So next, we'll talk about containers, and I wanted to use the slide first and then get to the notes. Okay, so containers, and in general, Docker is one version, I guess, implementation of this container technology. There are other competitors as well. But since Docker is quite popular, we're just going to stick with Docker for our narrative today. So the idea of containers is that you can develop artifacts, generally software artifacts, like a model or a model prediction service or a data cleaning service, transformation service, whatever, like or some website monitoring service, whatever service you want. When I say service, you just think of some files which achieve some task, right? What you can do is you can do that local development on the left-hand side, create an image using those files. Okay, so create an image using those files such that, let's say those files were part of a Flask web service, okay, a Flask service. Okay, let's say you are actually doing model prediction, and so you have a model file, you have a Flask file, you use those two to define an image. Okay, from that image, every time you can create a container, which is like an image is like a snapshot or an starting object from which you can create a container. If you run a container from that image, you will be able to run exactly the Flask service that you could have done directly also. Okay, so for local development, image and a container don't make much sense. But then what you can do is you can ship off this image like a pickle file. Okay, you can ship off this image to a registry or to your teammates or to your friends, wherever, and they can also run a container from the same image. Okay, and they don't have to do anything else, no other setup, except of course something to run that image, in particular in this case Docker. Okay, so as long as they have Docker, they can run your image, they don't have to install anything else, and they will still be able to use the same service that you could use on your local machine. Okay, so what you've done is package your model and associated files, your Flask service, into that image, and you're distributing it. Okay, and not just for distribution, not for somebody else to run it, but also you can use that image send it to Google Cloud. On Google Cloud, as Google Cloud or AWS or other these Azure and so on, they have services so that they can use that image as a starting point and create like 100 clones, 100 containers out of it, which can run simultaneously. For example, if you have a huge scale requirement, or or you can snapshot it so that you can delete your machine, or you crash your machine, you come up with a new machine, you can clone from that image, and you get again the same service. So it's basically for portability of apps, or in general machine learning prediction services, machine learning transformation services, whatever they are. Okay, so that's what this image is trying to say. Hey, you create this slide is trying to say local development. You create your endpoint is typically an image construction, and then given that image, you can send it to ideally a registry, basically, or you can send it to any of these third-party machines, server 1, server 2, or any of these cloud vendors, and they can all run containers from the same image, just like you could have run it locally as well. So today we'll just try locally to create an image and maybe run it from it, so run a container from it. But once you create an image, it's just exactly like code or any other object. You can just zip it and not really zip it, but there are certain ways to send it, and other people receive it and run your code as is, without any other installation. So those of you come from Java, for example, right? So Java, if you use Java programming language, it's like JVM. So as long as somebody has a JVM running, then whether you write code in Scala or or Java or anything which is which runs in the JVM, right? So it's like the third party just needs to have a runtime environment. Okay, like in this case, somebody needs to just have Docker installed, and they can run your image. It's similar idea. Okay, so it's like portability like that. So no need for compatibility issues, except for, of course, Docker versions may also have breaking changes, but mostly everything else is resilient. Okay. Okay, so for containers and Docker module, list of tools. The first tool is Docker, which is what we'll see today. We may not get time to look at other tools, but the alternative installation that you can try out is called Podman. Okay, Podman is very similar to Docker. Both are ways to build images, deploy containers, and so on. They are different names, different, I guess, organizations. Podman is by a company called Red Hat, which is a big open source company that got recently acquired. Docker is also a big company. So we'll try with Docker here. Another couple of tools that we'll need is Minikube, and it's not really a tool, but YAML. It's a markup language. So it's a way to specify what needs to be done. So it's a way to specify your container, okay, or specify your image. Okay, so Minikube is for next lecture, so I will not discuss it now. Okay, or Minikube is for next lecture. Yeah. So command line commands are mostly Docker space something, just like SSH space something. We'll also prepend sudo. It's not actually needed. There are ways to get around it, but for simplicity, for keeping it on par, same as the nodes, I'll use sudo. So sudo docker space something. Okay, that's what we'll use. And later on, I think next lecture, we'll look at cloud services, something called Elastic Container Service. So there are a lot of acronyms here. AWS and GCP stand for the cloud vendors. ECS stands for Elastic Container Service. ECR stands for Elastic Container Registry. Okay, they're just some service, some registry. Registry, as I said, is a place where to put your images. And GKE and GCR are Google Kubernetes engine. So Kubernetes is a technology to manage containers. Okay, and GCR is Google Cloud Registry. Okay, so or Google Container Registry. Sorry. So those are the acronyms here, but we'll get to the last two bullet points later. Okay, including also Minikube and kubectl. We'll deal with it later. So for today, we really need Docker, and we'll install it from scratch on our server, so that you don't have to worry about Windows versus Mac versus Linux, all that issue. So any questions about this, where we are and where we want to go? Again, as I said, the spectrum is basically web servers, serverless, and then Docker, okay, in between. And and after that we'll switch context. Okay, so let's say we still want to serve ML models. Okay, that's one example that we've been using throughout from lecture 1. So the problem is compatibility, right? So serverless was on the extreme end, which is, by the way, costlier than the web. The first lecture that we tried out, where we started a EC2 machine and we started a Flask app. That's the cheapest. Okay, if you want to use serverless technologies, it can be costly. It tends to be costlier. If you keep things similar, if you compare properly, and in between you can use Docker technology to get something like the portability that serverless offers. Not portability, but the ease of use that serverless offers, but also at the same time not worry about scaling, security, maintenance, and all that stuff. Okay. So those are all the types of considerations you want to have the moment you want to go from your garage to a real life production setting, right? So for hosted environments, we had to work hard, and that we saw in the first lecture and even the second lecture. For serverless, there are requirements like you cannot have huge packages. For example, serving a PyTorch model on AWS Lambda is non-trivial. Okay, so serving a PyTorch model in general is non-trivial, but serving it on AWS Lambda requires some extra work. Okay, not just PyTorch models. Think of scikit-learn models. Serving scikit-learn models on AWS Lambda is doable, but requires extra steps, right? So if you don't want to be constrained like that, Docker are a good solution. Sorry, containers are a good solution. What they do is they allow you to run arbitrary programs in new environments and new operating systems and new whatever EC2 machines or whatever Google Compute machines. As long as you just need one common piece of software, Docker, right? Docker runtime. It's like the JVM concept I was talking about. So yeah, so as I said, so what is a container, right? So I want to not spend time on these bullet points, but directly get to Docker to say that. Yeah, I think I want to focus on only one bullet point out of these several bullet points here, which is that a container at the end of the day is a process. Okay, so on Windows, when you open Task Manager, you'll see a bunch of processes, right? Or both on Linux as well. On Linux, if you type PS, okay, PS is to type the list of processes running. So if you type PS, you'll see a bunch of processes. So container is essentially a process. Okay, within the process, your script is able to see other things, other resources like compute resources and network and all that. The process, a container process is such that the script running inside, for the script running inside, it feels as if it's a complete operating system. Okay, although it's just a process from our point of view, right? From our point of view, as in from the host, wherever the container is running, from the host point of view, is just a process like the Jupyter process or the Firefox process or whatever. But from the script point of view, script as in like our Python script, where it's a Flask script or whatever, it seems as if it's a full-fledged operating system. Okay, so that's the magic going on, where the script feels as if it's a full operating system, but from outside we know that it's not an operating system. It's just a single process in the whole in my laptop or on my machine. Okay, so that's what's going on. That's why it's super lightweight compared to a virtual machine, and we'll see that distinction in the next page. Yeah, so I'll skip discussing Elastic Container Service right now because we're not going to talk about it today. But it's just a hosted service where you can ship that image thing that I was talking about, an image object, and they can spin a container from that image and let the container run for you. Okay, so this is the portability thing. You create that image locally. You develop your machine learning prediction model, a model service, and then they can run the same service as us without knowing anything about your dependencies or any secret keys or anything else. Right? They don't need to know. It's agnostic. You don't have to worry about compatibility and all that. Okay. So for today, we'll just do local experimentation with Docker after going through the differences between Docker versus
virtual machines. Okay. Any questions? Container pros and cons are just exactly what is said. It's mostly for consistency. Whatever you do locally, once you wrap it up in an image, it's going to run exactly the same way, whether you run it on Mac, whether you run it on AWS, whether you run it on Google, or whether you run it on some other random server. Okay, it's consistent, portable, exactly because once you create an image, you can send it off like files to other places, and those images actually capture everything that's needed for your script to run. Okay, so all the NumPy, SciPy, all the pandas, all the packages, the actual executables are all inside that single file. Okay, it's like a zipped folder. And it's lightweight compared to a virtual machine, which we'll see in the next page. Okay, so these are some pros. Cons, of course, there's an extra layer of extra tool. Like we saw how to run a class cap on bare metal on our virtual machine, right? You literally had to do Python space class file name.py, and you were able to create that web server, and it was so simple, right? So adding this extra technology requires somebody, your resources, your team members know Docker technology, know how to use the commands, know how to not, cause issues, right? I mean, with every new technology, there's a learning curve and all that. So there's all that extra stuff. Okay. I mean, especially if you're a solo developer or if it's a small team startup or something, you probably don't need Docker. I guess that's my comment here. Okay, so let's actually look at some moving parts of Docker, and then we'll actually get to a practical in a few minutes. Okay, 5-10 minutes. So, okay, so what is Docker? So Docker is an implementation of container technology. Okay, so it's basically, I mean, as in their words, it says, it's a platform for developing, shipping, and running applications. In our case, it's machine learning applications. Okay, and so let's take a quick overview of what Docker involves. Okay, so so this container, which is a loosely isolated environment, by the way, so that's exactly, that's why I guess the word container, it's an environment where your process, your Python file name.py, it feels as if it's in a complete operating system, whereas it's not talking to the original, the operating system. Okay, it's actually just from its perspective, it's as if it's seeing an operating system, but it's not. Okay. So its container is like a wrapper around your script, basically, and we can run just like in a single operating system. We can run hundreds of processes. I mean, if you open Task Manager, you'll see hundreds of processes. Similarly, on a single machine, you can run hundreds of containers. Okay, so it's kind of lightweight like that because each container is essentially a process. They're lighter on resources compared to virtual machines because they are processes. By which I mean, because they're processes, they're directly being controlled by the kernel or the core, program that is the core of an operating system. Okay, so I don't know how many of you have heard of Windows kernel or Linux kernel and so on. So that kernel is like a core program which controls everything in that machine. Controls everything in the sense that resources like keyboard, resources like mouse, resources like memory, resources like CPU, resources like printer, all resources that you kind of are all kind of controlled by the kernel. Okay, so you can see here CPU, memory devices, it's all controlled by this blue thing. And the blue thing is what allocates resources. Hey, if an application, so applications are processes, they want some resource. Hey, give me 5 MB of RAM because now I need to load a CSV. They need to ask the kernel, and then the kernel will say, hey, here's 5 MB of RAM, right? So all applications talk to kernel, and so similarly, containers, which are also processes, talk to the kernel and directly use the kernel's capability to get resources like RAM or some storage space and so on. Okay, so that's why they are lightweight. That is in contrast with a virtual machine, which doesn't do that, doesn't do exactly that, and we'll see that figure in later, few steps down. So let's talk about Docker engine. Okay, so let's talk about Docker and ecosystem completely. So the Docker ecosystem consists of a server, a client, and a protocol, an API to talk to the server. Okay, so there is three parts: a server, a client, and a way to talk to the server. Okay. And these three together are called, I guess, the Docker software or Docker engine. So when you install locally Docker on Windows or Mac, or now we're going to install it on our Linux machine, the remote machine, it comes with both the server and the client. Okay, the server starts and keeps running just like Jupyter server. And the client, of course, it's just a client program. So whenever we type Docker space something, it's a client program which is talking to the server, which is running behind the scenes. Okay, so so if you look at this, so a server is also called a daemon. Okay, so it's just a long running process, and there's a particular dialect, just like we saw the HTTP protocol to talk to a server and get predictions and so on. There's a particular dialect that they use behind the scenes for the command line utility Docker to talk to the server program. Okay. Now, if you look at really in terms of like a layered view, the innermost layer is the Docker daemon, the server. Okay. Through some protocol, through some language, protocol language is the same thing, through some language like English that I'm using right now, through some language, a Docker client can talk to that engine or Docker daemon. Okay, so a client can talk to the daemon, and client by talking to the daemon can work with containers. Okay, so we need a little bit of language just to say, hey, how do we deal with containers, right? They're not like files. They're not exactly like files. They are somewhat objects that are kind of new to us. So this client tells the server, hey, create a container for me. And so you can create a container. The client tells the server, hey, let's create a image or manage an image. Let's delete an image. Let's rename an image. Client tells the server, and that's how you kind of deal with images. Okay, images, as I said, are like the starting points from which you can create containers. Similarly, the client can tell the server, create hard disks for the container or create a network for the container and so on. So there are many functionalities that you can do using this Docker software. Okay. Any questions about what's going on here? I think it's clear. Okay, so here's the same idea shown horizontally, where on the left side you have the client. In the center you have the server, server program, the blue box, and then on the right side you have what is called a registry. And registry is, just think of it as a storage location, just like think of GitHub or Docker Hub, or there are different names here, but just like GitHub, there's something called Docker Hub that where you can put images. Okay, so client is going to issue commands like this. Okay, so Docker build, Docker pull, Docker run. We're going to talk about these commands later. Client issues commands. The daemon, which is this Docker host is just the our operating system or our remote machine. Docker daemon is the one which is orchestrating everything. Okay, it gets this command and sees, hey, Docker build something. So what should I build? I should build maybe an image. So it builds something called an image. Okay. Docker run. Hey, I need to pick up an image and run a container. Okay, so that's what it does. So that all the things, containers, images, are touched by Docker daemon. Okay. And then you can also say, hey, client can say, hey, Docker send this image to the registry, and then Docker daemon will say, hey, let's send something to a registry. And Docker can also talk to the registry and get an image if it's not there locally. Okay, so it can do all these operations. It's very similar to any other operation that you have seen, like you talking to some more heavyweight program that does all the things that you want, right? Okay. So although here we have listed a few things like what is a Docker registry, as I said, it's a stores Docker images. What are Docker objects? There are several objects, but we will be primarily interested in images and containers. Images, as I said, are starting points for creating containers, and we'll see in a couple of minutes how to create one. An image is created using what is called a Dockerfile. Okay, and so we'll see an example of a Dockerfile today. And this is an example of a command that we can run to, for example, run an Ubuntu image or a container, which is like an Ubuntu operating system. Basically, looks like an operating system, but it's not a separate virtual machine, or it's not a separate operating system. It's just a process from the host computer's point of view. Anyway, so we'll get to those commands in a second. So let's actually one final time look at the difference between a VM and a container, okay? Because I didn't kind of tell much about VMs. So so the left hand side shows how a block diagram of how container sits on the actual virtual machine, or actually the real machine, like a computer like a EC2 machine or a physical machine. Okay. The right hand side is a diagram, again, a blocks of how programs run inside a VM which can run on a machine. Okay, so you can see that generally there's infrastructure. Infrastructure means like a laptop or a physical workstation or whatever it is, or a virtual machine. Let's focus on the left hand side. Generally the virtual machine or whatever laptop will need to have some OS, like a Mac OS, Windows, or Linux. That operating system will need to install a program called Docker, and Docker containerizes apps. Okay, so you can see the one highlighted in white is one container. Similarly, you can have another container for the left side, one container for the right side. So all that is taken care of by the Docker program. Each one is a process. Okay, like as I said, task manager process, it's just a process. Now on the right side, you can see that physical infrastructure is whatever it is, like CPU, RAM, and all that. And then instead of a host operating system, you can have a host operating system as well, but there is a tool called hypervisor. Okay, so that tool, using that tool, you can create guest operating systems. They are full-fledged operating systems. Okay, so you can use VirtualBox, I think listed in the notes. You can use VMware Fusion. You can use Parallels Desktop. There are many software vendors who help you create guest operating systems. Okay, so those operating systems will have their own kernel, their own task manager, their own processes, within which you don't have to now anymore containerize, because you're already in a virtual machine. You can just run your app as is, like Flask file name.py. In fact, when we spun up an EC2 machine, okay, it's not that Amazon gave you an actual machine that's running in the data center. Okay, what Amazon gave you was actually this white block. Okay. They just said, hey, while choosing your machine, you said, hey, I want Ubuntu machine, T2 micro, and all that. Eventually, they will just give you one of these white blocks. And so there could be multiple machines, like your machine, my machine could be running on the same hardware in an Amazon data center. Okay, but they are virtualized. They are kind of isolated, all the way at the kernel level. So if there's a kernel vulnerability or some, malware or something that affects your kernel, your Ubuntu machine, although you're on the same hardware, your Ubuntu machine is not going to spill over to my, let's say, CentOS machine or Windows machine, although it's on the same hardware, So that's the isolation that virtual machines provide. Whereas containers, you can run containers in any host operating system, whether it itself is a virtual machine or not, it doesn't matter. In fact, today we'll be running within our EC2 machine, which is actually a virtual machine, we'll run Docker. Okay. Any questions about this, like differences between virtual machines and Docker? Everything's good. Okay, so let's, if so, then let's actually get started with Docker. So let me switch over. Okay, so sorry about this. Yeah. So you can actually download Docker from here. So Docker has its own, by the way, licensing details. Recently, they made it not free for organizations and so on. So there's a, but you can use it for academic and personal purposes. You can use it for free. So go to docker.com, that link, and you'll say Docker for Docker desktop, Docker for Windows, Docker for Linux. We'll just use Linux because we want to install it on the remote machine. Okay. If you want to try it on your local machine, feel free to do so, but commands will be different. Okay, and so you may be hitting bottlenecks. So the first time if you want to do it, I would suggest just do it on Linux. Okay, so it says, hey, for all these platforms, it's available.
So we have to download this directly on the virtual machine.
Yeah, we're gonna do that one virtual machine. So I'm just trying to find the link. Okay, not the right page. Let's actually click on Ubuntu. I mean, we just use Ubuntu, but Ubuntu has several ways of. Okay, let me click here. So they actually give you several ways to install Docker. Okay, so as I said, to reach the same goal, there are like a million ways to do that. So okay, installation methods. Okay, so it says most users set up something, some users download something else, and the last we'll actually do this last one. Okay, which is automated convenience scripts to install Docker. But if you are interested, you can try the other ways. So let's try the convenience scripts. Okay. So this is the script. Okay, so it's just saying run a command called curl. We just saw how to run a curl when if you want to hit any website. In particular, we're gonna hit this website called get Docker. So you can copy this and then go to our machine. I don't know what's going on here. Okay, so
Here it is.
I just use clear. Oh, how did I exit from there? So if I was looking at let's say something like Vim, and it's not showing it properly anyway. Escape shift colon Q will give you. Okay, so let's actually
Basically the command for like saving the changes and exiting the file, right?
saving the file and exiting is shift colon WQ. Write and quit. Yeah, I think I know it's like so many tools to learn, so many commands to learn. I would suggest whenever the need arises, you Google for that or whatever,
There was
search
a
for.
list account on the internet which had all.
Yeah. Okay, then maybe you should share it.
But it was for like
Share it on the chat. Yeah. Or share it on the discussion board. We have a discussion board as well. Yeah, sorry. So let's actually.
it was more related to coding.
Okay, so I don't know why there is some extra string there. Okay, so curl and we're just creating a file. So what is this doing? It's just hitting this website and saying create a file called get-docker. Okay, that's all it's doing. So if you look at what changed is there's a get-docker.shell script that got created. Okay, this is the file that got created when I ran that. Let's close all this. Yeah. So when I ran this command line command, so it just says create a shell script. Okay, a shell script again is like a different language, just like Python. It's a script which has a sequence of instructions for doing something, right? If you want to actually see the script, it's it is a huge script with lots of lines. So I will not. I just briefly opened it. So okay, next, what do you want to do? Dry run is equal to 1 means it will just show you what it will not install it, but it will just show you what would happen if you run the script. Instead of that, we're gonna drop it and actually run it via sudo command. Okay, so we'll actually directly use this command here. Okay? Sudo sh get docker .sh. Okay, is that clear? Anybody confused? Okay. So before that, I want to quickly check how much disk space we have. So we have 23 gigs available. Okay, I use the command. Again, you don't have to remember these commands. I assume it's getting recorded. So I'm just trying to check that we have enough space so that if we install Docker does take space. So that's why I think in the first lecture we created a bigger hard disk. Okay, so we have 23 gigs. So it should be fine. So okay, I ran sudo shell. I mean, sh is again for some shell choice. Get docker.sh. Okay, so we'll run a bunch of commands, and eventually you'll get the Docker prompt on your terminal. Okay, so looks like it got installed. It also suggests if you want to run Docker as a non-privileged user, which means if you don't want to use sudo commands, then you can do some extra stuff. For now, let's for simplicity, let's just keep the default. Okay, so once you run that command, so you can try version to see if it is installed. Okay, so it should say some version number. Docker version here it's 20.10.12. Okay, now so we actually have Docker installed. So let's try Docker run hello world, and I'll tell you what's happening, and it may fail. It may fail because of the sudo command which is missing, but let's try running it. Okay, so it did say fail. That's because if you try to run Docker, run a container, okay, without being root, then you have to you'll see this error. Okay, permission denied. So okay, let's so we ran sudo docker run and it ran something. So what did it do? What did this command do? Right? Remember, Docker is a command line interface to talk to Docker daemon. Okay, Docker daemon is running behind the scenes in the same machine. Okay, in our same remote machine. And so we are saying when we say Docker minus version, it's asking, hey, Docker daemon, tell me what version it is, and it responded with this is the version. Now, when we ask Docker run hello world, it's not the Docker CLI, which is this command line program, is asking the daemon, hey, run this image called hello world. Okay, so generally you say run image name. So it's so image name is hello world, and so the Docker daemon says, hey, I couldn't find the hello world image locally. That's what Docker daemon behind the scenes is seeing. Then it says, okay, it's not there locally. Let me pull that image from a registry. By default, it's going to pull it from Docker Hub. Okay, Docker, the company, has its own public, I guess, place where it lets people, share images. So it's getting that image from Docker Hub. Okay, and then it's saying, hey, I got that image. Okay, and then
There is an image saved in the Docker hello world.
Yeah, actually, in fact, let's actually see. So this is the location. Explore. Let's explore. And then type hello. This is the image. Okay, this is the official image, and that's why, that's kind of it's easy to reference. Otherwise, you would have to give Docker run, Teja/hello world if I had shared some image. Okay, so anyway, so let's actually we can even run this command again to see it will not pull again. It will say it's already there if you run this command, for example. So anyway, it downloaded that image and then it ran that image. Hey, it's available, and now it's actually creating a container from that image. Okay, that's a step 2 because I wanted it to run from that image. Image was not found, so first it actually downloaded that image. Okay, that was step 1. Step 2 is actually run from that image, and running that image just says this. Okay, hey, this shows that your installation is working properly. And it's actually telling exactly what I probably just explained. Yeah, so that's what happened, and it's saying if you want to be ambitious, you can actually run an Ubuntu container. Okay, while running this command. Okay? Again, it says Docker run. IT means, I guess, interactive terminal or something. I don't remember the exact help. I mean, we can check the help in a second. And run Ubuntu image, run a container based on Ubuntu image, and run the program called bash. Okay? So this is a way to run a different thing. So let's actually move forward. So if I type sudo docker images, it will tell you what images are available right now. So the only image available right now is hello world because we just got it from a public repository or a public registry. Okay. If you run this command, for example, it's going to start downloading Ubuntu image. For now, I'll say pause on it because we don't need it at the moment and it takes some time to download. But it will download the Ubuntu image and then run a container based on it. But what we want to do is actually directly get to our situation. So we have a Docker example here. Okay. So let's actually try out that example directly. Okay. So let's see what's there in there. There's a Dockerfile and the Flask weather service. Flask weather service is exactly the same as, in fact, we could copy the file from the Flask weather service folder from the other another folder. But let's actually see what's there in the Dockerfile. Okay. And what is there in Flask weather service? It's exactly the Flask app that we already know. Okay. So yeah. So let's actually see. So let's actually try running it first, and then actually, what do we need? What do you want to do first? Yeah. So what we're going to do is, this is a plain text specification of an image that we want to create. Okay. That image, what we want to do is store our Python file. Okay. So this is very similar to, remember, we wanted to be it to be portable and all that. So the second person who gets this image doesn't need to know what's behind the scenes inside the image. Okay? All they wanted is the functionality that you want to give via this image, right? So what we're doing here is create an image. This zip folder kind of an object. Okay. So what does that image do? Start from some existing image. Okay. So generally you need to start from some image. So we're saying, hey, start from a Debian image. Okay. Debian is like Ubuntu, smaller. Maybe you can change it to something else. Start from some existing image. This is just optional. You want to give your name, and then it's saying, hey, update all the packages. And in particular, I want Flask and a couple of other related packages I want installed. Okay. So it's not using Conda. Okay. It's just saying, hey, apt-get update. I think we saw in the first lecture. Apt-get update is just update the programs in the computer in this machine. Not exactly. So update the program information that I know about, which is relevant to this machine. And then it's saying install Python. And then it's saying change to the directory. Then it's doing some symlinking. And then it's saying install Flask. Okay, so don't worry about each of these lines. The point of number 3, which is highlighted in green. By the way, greens are like the sequence of commands that we are issuing in this text file. Okay, to create our image. So the green command run is just asking us to run some program, and the program is saying, hey, install Python and install Flask and a couple of other things, GeoPy and request, and that's only because we wanted to have weather prediction service here. Then the next command is saying, copy Flask weather service that's there in the current working directory in my local development into that image. Okay, so I'm copying my Python file that I have curated into that image, and then it's saying, hey, when this image is run, when anybody wants to run a container from this image, run this command, which is Python space Flask weather service.py. Okay, that's all. It's just saying, hey, run this Flask weather service.py whenever somebody wants to create a container out of this image. So this is like a complete specification of what do you want to have. Like it's a wrapper. It's saying, hey, start with the Debian, some smallest operating system like thing, install Python and some required packages like Flask, GeoPy, and request. Copy my file and make an image out of it, such that when somebody wants to create a container from this image, my Flask weather service.py will run. Okay, that's all going on here. So from this we can create an image. Okay, so right now you can see that there is no images. So if we do sudo docker images, there's only hello world image, which we already ran. Okay, so what we will do is now use the command line utility to talk to Docker daemon to say, hey, let's create an image. Okay, Docker build image and give a name to it, a tag to it. Let's call it weather. Okay, and then dot to specify where can it find the Docker file. Okay, so it's just saying I'm in the correct directory, or I'm not in the correct directory. Sorry, so I should actually. So if I run this, it will not work. It says sorry. Actually, I'm not in the right directory even. So let's actually go to mlops and Docker example. Now I'm in the Dockerfile thing. So much. Okay, let me actually not even do that. So sudo docker. Oh my God, this is not working well. Let me use the as example. Oh no, I can't change the directory here, right? Okay, so I'm in the Docker example folder. Sorry, I think I added an image in between last time. So just saying a Docker build image with a tag weather using the current Docker file. Okay, so let me. I just press enter, shift enter. I'm just saying, hey, now I'm going to create that image for you. It's saying, and it's showing the 5 steps. Why are there 5 steps? Because there are 5 steps here from maintainer, run, copy, and entry point. These are the green parts, which are 5 steps. Okay, so it's doing a lot of things here. Let's actually ignore all that. Okay, okay.
Just opening one file text.
No, it's actually, I should have run it on the command line. I'm running it here. So it's just spitting out all sorts of. So in the step, if you see in one of the steps here, I'm saying update my machine, right? So it's just doing all these background things first, which is like lots of lines. And then if you see step 4, copy flask, it did that. And then step 5, setting the entry point. Okay, so those are 5 steps that it had to set, and it created that. So now actually let me get back to the, oh my God, the terminal. Okay, sudo docker. I think for some reason it's acting up. Okay, so let's actually just use it. Okay, so you can see that now there are 3 images. First one was there when we tried to say Docker run hello world, right? That was there. Now when I try to create this weather image, okay, it needed the Debian image, some starting point, and so that image was downloaded as well, and then it created my weather image. Okay, so now I have my weather image. What I can do is just call Docker run to run this weather image. Okay, so let's try that. Okay, so very similar to sudo docker run hello world. I just created this image from which I can create containers. Containers are ephemeral things, throwaway things. They just get created from this weather image. Okay, so okay, so actually that's not the way I should have run it, but you can see that when I said run, it says serving class weather service. It's available at some IP address. Okay, so the right way to run it was to do port forwarding. I didn't do that, so let me. So I made that. So the way you want to run it is sudo docker run minus daemon, okay, in a daemon mode, as in I want to run it as a background service because it's a weather service. I want to make queries to it and get weather forecast back, okay. And I want to do port forwarding, very similar to SSH port forwarding, okay. So I want Docker daemon to tell me, hey, you're running something in a container. It's running on some port 5000. Can you expose this to my machine's port? Okay, this machine is actually the remote machine, this AWS machine, but that's fine. I think we can port forward 5000 to 5000, okay, because the by default Flask app runs at 5000. And press enter. Okay, so now you didn't see that log. Okay, now how do we know it's running? You can do sudo docker ps. Okay, ps is all the processes that Docker daemon is controlling. You can see some name here. So it says, hey, container ID is something created from the image weather. What is the command that was run? Python Flask. Created at some point. It is running from some time, and port is like local port, whatever it was is forwarded to the port of the machine, and it has some arbitrary name also given here, vigilant something. Okay, so now what we can do is curl. Okay, so you can curl to that port and pass like pass a we've seen this example. So pass a get argument. Okay, so tell me the weather of Chicago. So here is the full printout of weather of Chicago. It's not nicely formatted, but basically the point is this localhost 500 is actually I'm not running this Flask app locally, right? So this Flask app is running inside a container which Docker ran. Okay, so Docker ran from an image the container's port was forwarded. I was able to query that container, and the container went ahead and fetched the weather information of Chicago and is showing it here. Okay, you can actually also expose this to the world. I didn't do that. Okay, so I opened the port 5000. So now you should, I should be able to access this will achieve the same as what we were doing even in the first lecture. From any browser, you guys can also try this IP address because it's public. But if you try this link, then it's from any machine like your machine. It's going to my AWS machine. From my AWS machine, it's going to the Docker container that's running. And inside the container, the Flask app is running, and that's actually fetching weather information and showing it to us. Okay, so here since I did not pass anything. Right, so this is the isolation that we achieved. So now what I can do is the image that I created, I can share it with everybody, and they don't have to be worried about anything else. They just have to do Docker run that image, and they'll be running a weather service just like that, right? So they don't have to be worried about Python setting up dependencies like GeoPy and Flask and all that. It's not needed. Okay, as long as they have Docker installed somewhere, they can run any image. But I need to share this image somewhere, and that can be done on Docker Hub or Google or AWS and so on. Okay, so that we'll see next time. So we're already out of time. If you have any questions about Docker, you can stay back and ask. Or next time we'll try to work with cloud services to set up, to send our image to the cloud service to run it, and also start working with Kubernetes. Okay. So what's it?
You said you're going to start working with
Kubernetes. which is just a container orchestration package.